This diagram represents the architecture we built in the last episode. By installing prompt chaining, routing, and parallelization, we created a baseline for efficient AI workflows. However, even a high-speed system like this can fail when assigned an ambiguous, multi-step task with real-world stakes. It can hallucinate facts with absolute confidence or rely on historical training data instead of current reality. Without oversight, it eventually loses track of your primary objective. Raw computational speed is useless if the final output is confidently incorrect. To build systems we can actually trust, we must install 3 specific design upgrades that give the agent foresight, physical reach, and the ability to correct its own mistakes. Large language models often produce a suboptimal first draft that lacks nuance or factual rigor. This flowchart illustrates the reflection pattern. We build a feedback loop directly into the architecture, allowing the agent to evaluate its own work against a set of standards before providing a final response. We can make this even more robust by dividing the mind. Here, one agent acts as the producer, generating the work, while a separate, specialized agent acts as the critic, who provides the feedback. This pattern requires a trade-off. You are sacrificing processing speed and increasing API costs in favor of accuracy and detail. Reflection transforms the agent into a quality-controlled system that moves beyond simple text generation. Even a self-correcting agent is limited if it is restricted to its historical training data. The tool use pattern acts as a cognitive bridge. It allows the agent to interact with current data in the digital and physical world. The agent recognizes gaps in its knowledge. When it needs a current fact, it pauses its internal generation process. It then formats a request to an external API, like a search engine, to fetch live observations before resuming the workflow. Tool use connects the model to external systems. Instead of relying on educated guesses, it can verify exact facts, run code in a sandbox, or trigger real-world actions. An agent equipped with tools and self-correction can still become lost if a goal requires dozens of distinct steps to complete. That brings us to the planning pattern, which installs the architectural capability of foresight. This plan demonstrates the concept in action. Before taking any steps, the agent decomposes a massive, ambiguous goal into a sequential roadmap. This roadmap ensures the investigation is resilient to single-point failures. It also allows the user to disengage while the agent manages the work. Planning equips the agent to act as a strategic operator, steering the system toward long-term objectives. Zooming out, we see an autonomous entity possessing reflection, tool use, and planning. This architecture is built for adaptability. It moves beyond traditional programs that break when they hit an unexpected obstacle. It functions like a dynamic GPS, observing its environment and calculating alternate routes to the objective. This is the shift described by Marco Argenti, transitioning from telling a computer what to do to explaining why we need it done, and trusting the architecture to figure out the how. But what happens when a single task is too large for one mind to manage? That is where we move into multi-agent collaboration.